Hi everybody, this video today is going to go through the AP workbook through the problem on 2E. So let's take a second to read through the scenario. Two blocks are being pushed across a surface with an external force F as shown in the figure at the right. The mass M2 of block 2 is greater than the mass M1 of block 1. The blocks begin at rest. The surface is smooth enough that the frictional forces between the surface and the block can be neglected. So we're going to draw some free body diagrams. This will correspond to M1 and the other one will correspond to M2. We want to draw the relative lengths of all the vectors to reflect the relative magnitudes. So M1, this is the force of gravity from M1. And this is the normal force of M1. And then this is the force, and I might call this the push force. So this is the push force that's going on. Okay, well, what is this force here? This is the opposing force. If you're pushing M1 against M2, then M2 has to be pushing against M1. So we're going to call that force of M2 of 2 on 1. So that's the free body diagram for box number 1. Okay, for the second box, we didn't do this before, we should have. Now we're focusing on M2. So what's going on here? Well, we can see that there's a force here, and of course if there's one down here, there's also the one going up. But there is no force over here on the right. And I might have said that a little bit backwards a minute ago, but actually I didn't. But let's take a look at what I did say. Okay, first of all, this is the force of gravity from block 2, the normal force of block 2. And this is the force from M1 onto M2. Okay, and let's just kind of inspect a couple of things. There is a person or a force pushing it. And they begin at rest. So they're beginning at rest, but they are getting pushed, and there is not enough friction to talk about. So if there is a force going on, this is going to continue to accelerate. So we are going to have a vector, a net vector that is going to the right. The other piece I said that there's not a force over here on the right. What I meant is there's not a force acting on the right-hand side towards the left, right? So there's no arrow over here because nothing's pushing against it here. This arrow is representing right at that spot, right there, that M1 is hitting on it and pushing it that way. Okay, now the next section is kind of like a two-column proof in a way. It is a way to lay out an argument, and it's just like taking us through step-by-step how to do that. And that's what a two-column proof does also. Two-column proof allows you to go step-by-step and lay out your argument using logic. And that's what we're going to do here. And also, with a two-column proof, I consider that like an outline. And then from that outline, you could write a paragraph. Same thing here. We are starting an outline. It's not going to ask us for a paragraph today, but by the time we get to the AP test, we ought to be pretty good at writing reasoned arguments. Okay, so they start off saying the sum of the forces in the x direction is equal to m times a in the x direction. So then they explain it. The sum of the external forces of the system will be equal to the mass of the system times the acceleration of the system. That's just Newton's second law. Then the net external force in the horizontal direction is F sub push. Okay, so the net external force, they're talking about this sum of the forces in the x direction. So they're saying, instead of calling that sum of forces in the x direction, let's call it F push is equal to MA sub x. And that should be a sub. It was just kind of hard for me to make my sub so small. Okay, then they say the mass of the system is the sum of the two masses. So we didn't even talk about that. We were talking about up here, we did M1 and we did M2. And we never even talked about, well, what about the entire system? And we ought to analyze the entire system. In fact, we could just take a second to do that. If we drew our free body diagram, this would be the force of gravity on 1 and 2, or the total, which means we have a normal force going the opposite way. And you can see the only force acting upon it is this one here. So this would be the whole system, would be this. Okay, let's get back to our argument here. So the mass of the system is the sum of the two masses. So again, with our two-column proof, our geometry proof here, we're bringing down the force of push here, and all we do is sub in for the M1 plus M2. And now they're saying the acceleration of the system is then what? So we need to solve this for A, acceleration. And so we just need to divide both sides by M1 plus M2. So I get the force of the push over the total mass. That's the acceleration. And then it says, and since mass 2 will have the same acceleration as the system, the acceleration of mass 2 is the same thing. Okay, that's the same thing. We just subbed in a 2 for that block. So that block is going to have the same acceleration as the whole system. Now that makes sense, right? Whatever block A, whatever acceleration it has, it's going to be the same thing for block block 1 and block 2. Okay, let's go to the other page. Let's say we put a third block in here, M3. And let's say it's added to the system. Now we have the same external force going on. So this person, it has the same amount of strength they had before, same force. Indicate whether the magnitude of the acceleration of block 2 is now larger, smaller, or the same as in the original situation, and justify your answer. Okay, there are a couple ways that you could go about this. There is the force that is the same force as it was before. However, there are the blocks, there are more of them than there were before. So if we have the same force but yet more mass, what's going to happen? Okay, I'm a math teacher, so I like to think about things mathematically. If this is what I came up with at the end of my 2-column proof on the other side, if my push does not change, and yet I add another mass here, well, now what's going to happen in acceleration? It's going to become smaller, right? Because you have the same amount of push, but you've added more stuff. So it's going to be a smaller acceleration. Okay, how should we word that? Here is what they've said in the answer key. The magnitude of the system's acceleration is now smaller since the system is more massive with the same net external horizontal force. So the acceleration of the system is equal to the acceleration of block 2, which is now this. And so notice that they have incorporated an equation, just like I did on the other page, but they also explained it. And that's going to be the thing that you need to be able to do, is give something concrete and also give some explanation with it. All right, that wraps up Workbook 2E.